Morning students, all of you. In last class we studied acid-base salts. In that we studied Arrhenius theory, Bronsted-Lowry theory, Lewis acid-base theory. And after that I taught you types of salts. So in that types of salts, three categories we studied: simple salt, polyatomic salt, and complex salt. Now see today, write today's date. Write heading acid radicals. Write today's date. Write heading acid radicals. Now see what are acid radicals? Means the one that is obtained from acids. And acid radicals are also called anions. You know, in 10th standard, later we study crisscross method. Means in order to write the formula of the compound, we will write formula of the compound by crisscross method. So before writing crisscross method, students should know what are the acid radicals, what are the basic radicals. So understood, acid radicals are called anions. Copy this. Acid radicals what we call anion. Anion will bear what charge, students? Anion will bear negative charge. Cation will bear positive charge. Now in this acid radicals, we have monovalent, bivalent, trivalent, tetravalent. Monovalent means what? Whose valence is 1. Bivalent means what? Whose valence is 2. Trivalent means what? Whose valence is 3. Tetravalent means 4. So we divide these acid radicals into 4 categories, right? One monovalent. Monovalent. What does monovalent mean? Whose valence is 1. So here write monovalent. Monovalent means valence is 1. Now what are the monovalent anions we are having? Chlorido. You know chloride ion. Cl minus is chloride ion. Anion. This is chloride. Next write Br minus. So Br minus is what? Bromide ion. All these radicals you have to remember. The third one, OH minus, what we call hydroxide ion. Cn minus. Cn minus is called cyanide ion. O minus, O2 minus. This is called superoxide. And you know MnO4 minus. This is called permanganate ion. You know potassium permanganate, oxidizing agent. This is called permanganate ion. Permanganate ion. ClO minus. Hypochlorite ion. ClO2 minus. Chlorite ion. ClO3 minus. Chlorate ion. See the difference? This is chlorate. ClO4 minus. Perchlorate ion. So these are all monovalent. Copy this: chloride ion, bromide ion, hydroxide ion, cyanide ion, superoxide ion, permanganate ion, hypochlorite ion, chlorite ion, chlorate ion, perchlorate ion. And you know SCN minus. Thiocyanate ion. So these are all monovalent. Monovalent means what? Whose charge is -1. Understood? So all these anions you have to remember. Chloride means Cl minus, bromide, hydroxide, cyanide, thiocyanate. Because by knowing this, we can write formula. In organic chemistry, it will help you. And permanganate ion is MnO4 minus. Hypochlorite ion is ClO minus. See the difference. This is hypochlorite ion. This is chlorite ion. This is chlorate ion. This is perchlorate ion. This is thiocyanate ion. And see, I write here nitrate ion. See the difference between nitrate and nitrite. Nitrate ion. Nitrate ion is shown with NO2 minus. Nit this is NO3 minus is nitrate. Nitrite ion. See the difference, students. Nitrite. If nitrite ion would have been asked, see the difference. NO2 minus. This is important. Nitrate ion, nitrite ion. See, nitrate ion is NO3 minus. Nitrite ion is NO2 minus. And see one more NH2. You know ammonia. From ammonia you remove one H. This is called amide ion. Amide ion. Amide NH2. Ammonia you know no NH3. From ammonia you remove one H. That makes amide ion. Amine ion. Amide or amine ion. So these are all monovalent ions. Copied. Now we go for bivalent ion. So what is meant by bivalent? Whose valence is 2. Copied all of it. So this list you have to remember. Chloride, bromide, hydroxide, cyanide, superoxide, permanganate, hypochlorite, chloride, chlorate, perchlorate, thiocyanate, nitrate ion. See the difference between nitrate and nitrite ion. This is nitrite ion. This is amide ion or amine ion. Right, next bivalent ion. Right, bivalent. What is meant by bivalent, students? Bivalent means what? 2. Right, bivalent ion. Now, what are the bivalent ions we are having? One is sulfate ion. So, students should know the difference between sulfate and sulfite. Sulfate ion. Sulfate ion, you remember, student, SO4 2 minus. This is sulfate ion. Sulfite ion. See the difference between sulfate and sulfite. Sulfite ion is SO3 2 minus. This is sulfite ion. Carbonate ion. Carbonate ion. You know, carbonate ion is CO3 2 minus. Carbonate ion. Manganate ion. You know, previously we wrote permanganate. Now I am writing manganate ion. Manganate ion is MnO4 minus 2. This is manganate ion. Dichromate ion. You know, potassium dichromate, K2Cr2O7. Later you study oxidizing agent. Dichromate ion. What is dichromate ion means? Cr2O7 minus 2. This is dichromate ion. Peroxide ion. Peroxide. Peroxide means it will have OO linkage. See, peroxide is shown by O2 2 minus. Disulfide ion. Disulfide ion. Disulfide ion. What is disulfide ion? S2 2 minus. Disulfide ion. So these are all bivalent, whose valence is 2. sulfate, sulfite, carbonate, manganate, dichromate, peroxide, disulfide. Disulfide is S2 minus. Here, these are all bivalent. You have to remember, even if you are asking this. Sulfate, see the difference. Sulfate is SO4 2 minus. Sulfite ion is SO3 2 minus. Carbonate is CO3 2 minus. Manganate is MnO4 2 minus. See the difference between permanganate and manganate. This is dichromate ion. This is peroxide, disulfide. And write chromate ion. Chromate. What is chromate ion? CrO4 2 minus. This is chromate ion. These are all what? Bivalent ion. Understood. Now write trivalent ion. Trivalent will be very few. Right, trivalent ion. Trivalent means what, student? Valence is 3. Like phosphate ion. Now what is phosphate? PO4 3 minus. This is called phosphate ion. Later you get in chemical bonding. Phosphate ion. And see N minus 3. This is called azide ion. See the difference between nitride and azide. N3 minus is called azide. N3 minus. This is nitride. Azide will be, this will be nitride. Then what is azide? See, azide is N3 minus. N3 minus is called azide. This is monovalent, but actually I am writing here. This is azide. See the difference between nitride. Nitride is trivalent. This is monovalent, student. Actually, you have to write it monovalent, but here I am writing this is azide. This is nitride. N3 minus is nitride. So these are all what? Acid radicals. Monovalent, bivalent, trivalent. Now we go for next basic radicals. Copied all of it. So these formulas you have to remember, because later when you come in inorganic chemistry, in order to write formula of the compound, these basic radicals will help. Now write basic radicals. Right, basic radicals. Now basic radicals are obtained from where, student? Bases. Basic radicals are obtained from bases and we call them cations. These are obtained from bases and we call them as what? A cation. Cation will bear what charge, student? Monovalent. They may have single unicharge or bivalent, trivalent or tetravalent. So based on the charge we divide them into monovalent, same as in anions what we did here also. Write it monovalent. Monovalent means what? Same as in anions what we learned. Valence is 1. Right, monovalent. Monovalent cation. You remember in periodic table later we study S block elements, that is 1A group. 1A group will lose how many electrons, student? 1 electron. No, in 10th standard you must study lithium. Lithium valence is 1. Sodium, potassium, rubidium, cesium. These are all monovalent. And you know silver, D block element. Silver will, so lower will be us, higher will be ik. This is silver. Silver valency 1. And see here I am continuing Aurus. Au plus is called Aurus. Aurus is what? Gold. This is Aurus, student. Aurus. Aurus is what? Gold. So gold is monovalent, silver is monovalent, and see what else? Cuprous. You know cuprous, Cu plus. Cu plus is called cuprous. Higher is what? Ic. Cupric is plus 2. See the difference between cuprous and cupric. This is cuprous. Cuprous. Cu plus, right? Cuprous. And you know ammonium. What is ammonium? See the difference between ammonia and ammonium. This is ammonium. NH4 plus is called ammonium ion. Ammonium ion. These are all monovalent. And you know NO2 plus. Later in organic chemistry you study. Nitronium ion. This is called nitronium. Nitronium ion. NO plus. This is called nitrosyl. 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 So these are all monovalent cations. And all these cations you have to remember. Lithium, sodium, potassium, rubidium, cesium, silver. This is silver ion. And Au is what? Gold, Aurus ion, cuprous ion, ammonium ion. This is important. Nitronium ion. This is nitrosyl ion. These are all what? Monovalent cations. Here now we go for bivalent cations. Right? Bivalent. What is meant by bivalent, students? Valency 2. Bivalent cation. Now you remember in 10th standard in periodic table, S block they will be present on extreme left side. Second group elements like beryllium. Beryllium valence is how much, students? 2. Beryllium, magnesium, calcium, strontium, strontium Sr plus 2, barium. These are all bivalency. As well as copper we took here, no, cuprous. Now I am taking cupric. See the difference between cuprous and cupric. This is cupric. And you know zinc. Zinc exists as J-positive zinc ion. Zinc. And you know chromium. Chromium exists as Cr plus 2. This is chromium. And you know iron exists in plus 2. Ferrous. In ferrous Fe plus 2. Ferric plus 3. See lower is asam. This is ferrous. Ferrous. And these are all what? Bivalent ions. Beryllium, magnesium, manganese. You know manganese is a D block. Manganese ion. You know cobalt. Cobalt also exists as somewhat bivalent. Cobalt ion. And in this monovalent you can write thallium ion. You know this is called thallium, which belongs to 13th group, third group, thallium ion. These are what? All bivalent ions. Beryllium, magnesium, calcium, strontium, barium, cupric, zinc, chromium, iron, manganese, cobalt. These are all bivalent ions. Right? Trivalent ions. Copied all of it. So this list of anions you have to remember, because when you remember, formula of the compound can be written easily from by knowing the cation and anion. Now write within monovalent we completed, bivalent. Now write trivalent cation. Now what are trivalent means? What? Where valency is 3. Like trivalent cation. Trivalent. Trivalent means what, student? Their valency is 3. Let's write 1. Aluminium. You know aluminium belongs to third group. It will form Al plus 3. Aluminium ion. This is aluminium. And you know thallium. Thallium also exists in plus 3. Thallium ion. And you know iron exists in ferrous, ferric. Ferrous we wrote Fe plus 2. Ferric what we write? Fe plus 3. Fe plus 3 is called what? Ferric. This is called ferric. Here ferric ion. And gold, you know, previously we wrote Au plus, that is Aurus. Now the same gold exists in plus 3. This is called auric. Saw the difference, students? Aurus we wrote Au plus. Auric we are writing Au plus 3. This is auric. Higher oxidation state X. Lower oxidation state As. These are all trivalent ions. Aluminium, thallium, ferric ion, Aurus ion, and chromium, chromium also exists in plus 3 state. Chromium ion. So these are all trivalent. Now come to tetravalent. Tetravalent means what, student? Tetra means valency 4. Right, tetravalent. Valency 4. Very few will be there, like the silicon. Silicon valency 4. And stannum, Sn plus 4. It belongs to group 14. Stannous, stannic. This is stannum, stannic. And plumbus, plumbic. This is stannous. This is stannic we call. Stannic. Stannic belongs to group 14. So these are what? Trivalent ions. Trivalent means what? Whose valency 4. So with this all anions, cations we done. See, once check what are the first we discussed monovalent anions, then bivalent anions, then trivalent anions. With this anions completed, then we go on to basic radicals, monovalent, bivalent, and trivalent, tetravalent. Copied all of it. So these are what? Anions and cations. Now from this we can write what? Formula of the compound. So in exam they ask you formula of the compound can be written from anion and cation by crisscross method. So write heading crisscross method. Copied all of it. Write heading crisscross method. Writing formula of the compound from crisscross method. Right question. Writing formulae of a compound by what way? Crisscross method. Right, crisscross. Might be heard this in 10th standard, no? So see, for example, I want to write potassium dichromate. In exam they give you what is the formula of potassium dichromate. Then student, you have to know in this cation is potassium, anion is dichromate. So potassium valence is how much, students? Just now we learned the potassium valence is 1. So write plus 1. And dichromate ion. See, once list of anion. Dichromate ion is Cr2O7 minus 2. No? Now what we have to do? We have to crisscross the valencies. Below to that write valency of this is 1, no? And valency of this is 2. So this valency goes to this one. This valency goes to this one. So what will be the formula? K2Cr2O7. K2Cr2O7. This will be the formula of potassium dichromate. Understood? Simple, no? So potassium you have to know its valence is 1, and dichromate ion valence you have to know minus 2. Hence formula is potassium K2Cr2O7. Right, next B. Potassium permanganate. Now see, potassium permanganate. What is permanganate? You have to know permanganate formula. It is monovalent anion. In this is cation, no? So this is K plus. And what is permanganate? Once see the list. Permanganate ion we wrote MnO4 minus, no? MnO4 minus. This is permanganate. So what you do? Crisscross. This is plus 1 and permanganate valency also 1. Both the valencies are 1, so they will cancel. So formula of the compound will be KMnO4. This is potassium permanganate. Simple. So from crisscross method we are writing compound. Next write heading next compound, right? Copied all of it. So this is potassium dichromate, this is potassium permanganate. Next slide, sodium sulfate. Sodium sulfate. Sodium sulfate. Can you tell me what will be the formula? Sodium sulfate. Sodium sulfate. See the difference between sulfate and sulfite. Sodium is obtained from cation, no students? So sodium is monovalent, no? So this sodium will be monovalent, and sulfate, it is bivalent anion, no? So what is sulfate anion? SO4 2 minus. Now what you do? Crisscross. Sodium valency is 1 and sulfate valency is 2. So what you do? This valency goes to this one, this valency goes to this one. So what will be the formula? Na2SO4. This is what we call sodium sulfate. Right, fourth one. Cupric, cupric, cupric nitrate, cupric nitrate. Then student, you have to know cupric. Cupric is, what is the valency? Higher is Ic. Copper exists in what state? Cuprous and cupric. So copper you have to take here +2. What is nitrate? Just know nitrate. See, there are two nitrate, nitrite, nitrate. This is NO3 minus. So this valence is 2, this valence is 1. Crisscross their valency, student. This valency goes to this one, this goes to this. So then what will be the formula? CuNO3 taken twice. This is called cupric nitrate. Cupric nitrate. Understood? Cuprous. Higher is Ic, lower is As. Cupric nitrate. Right, fifth one. Barium phosphate. Barium phosphate. Now what is barium valency, student? Barium belongs to second group. Its valency will be 3, no? Sorry, 2. Barium belongs to second group. So what is the valency of barium? 2. Phosphate valency, this is anion, student. So anion will bear, phosphate will bear -3. So charge of this is 2 and charge of this is 3. Crisscross their valency. Then what will be the formula? Ba3PO4 taken twice. This is called barium phosphate. Barium phosphate. Understood? Barium valence is 2, phosphate valence is 3. So valency of 2 goes to phosphate, valency of 3 goes to barium. Barium phosphate. Next slide, Aurous. Aurous sulfate. What is Aurous, student? Aurous. Aurous means what? Gold. Aurous. AUROUS. Aurous sulfate. Aurous. Aurous is, what is the valency of aurum? Aurous, auric. There are two forms of gold. Aurous will bear Au plus. Sulfate will have valency -2. So crisscross their valency. Simple, no? This comes formula Au2SO4. Au2SO4. Understood? See the difference? Aurous, auric. Now write auric. Auric nitrate. Auric nitrate. Auric is also gold, no student? Auric valence is how much? 3. Higher is 3, no? So see the difference between Aurous and auric. This valence is 3 and valency of nitrate is 1. See, nitrate I am writing. So now crisscross the valencies. Both the valencies are same. 3, 3. So formula will be AuNO3. Auric nitrate. Next slide, barium azide. Barium azide. Now see student, barium valence is how much, student? 2. No? Barium is 2. Barium valence is 2. Azide. See the difference between azide and nitride. Azide is bearing what charge? N3 minus. Now crisscross, student. This is 2. This is 1. The valency of this goes to this. So what will be the formula? BaN3 taken twice. This is barium azide. See, azide. See the difference between nitride and azide. Nitride will bear N minus 3. This is azide, N3 minus. Next, right, sodium perchlorate. Sodium perchlorate. What is the formula? So, perchlorate, student, sodium valence is 1. Perchlorate valence is ClO2 minus. Sorry, this is chlorite ion. Perchlorate ion means ClO minus. Both the valences are 1. So, what will be the formula? NaOCl. Understood, student? This is 1, this is 1. Formula will be NaOCl, sodium perchlorate. Sorry, not perchlorate, hypochlorite. Sodium ClO minus perchlorite ion. What we wrote once is, should I show you that chlorite ion, ClO. Hypochlorite ion. This is hypochlorite. Hypochlorite, correct. Hypochlorite. ClO minus is called hypochlorite. Sodium hypochlorite. Formula is sodium hypochlorite. This is not per, make it hypo. Sodium hypochlorite. Sodium hypochlorite. NaOCl is called sodium hypochlorite. Right, next compound. Copy down all of the following. Last one, right? Sodium chlorate. See the difference between hypochlorite and chlorate. What is the valency of sodium? Sodium valence is 1. Right here, valency of sodium is 1. What is chlorate ion, student? See, chlorate ion, ClO3 minus. See, chlorite ion is ClO2 minus. Chlorate ion is ClO3 minus. So, both the valencies are 1. So, formula of the compound will be NaClO3. So, this is what a crisscross method. Understood? So, in order to write crisscross method, you have to be thorough with anion, cation, and in anion, whom are bivalent, whom are monovalent, who are trivalent. And in cation also, you have to remember who is monovalent, bivalent, cation, and the list of cation, anion you have to remember. Clear? Which is forming of a formula of compound by crisscross method done. Now, write next heading. Ionic product of water. Copied all of the next slide heading. Ionic product of water. Slide heading. Ionic product of water. This one we study later in equilibrium chapter. Now see, ionic product of water is shown with the symbol Kw. With what is the symbol? Kw we write. Now what is this ionic product of water, see student? You know water is a bad conductor or good conductor? Water is a bad conductor of electricity, you know. So here see how it ionizes. This water, it gets ionized into H plus ion and OH minus ion. No, when we put in water, water gets ionized into H plus and OH minus. Now for this we have to find out ionic product. See how we get a, later we study equilibrium constant. K is called what? Equilibrium constant, and this will be reversible reaction. Reversible means what, student? It can move both forward and backward. Why? Because it is a weak electrolyte. Water is a weak electrolyte. Getting my point what I am saying? Since water is a weak electrolyte, it will not completely ionize. It will be in existing in water equilibrium between what and what, H plus and OH minus. So for this we apply equilibrium constant. Now what is K called? Now onwards K is known as equilibrium constant. Now this equilibrium constant, see how we get a product concentration by reactant concentration. Here who is the product? This H plus ion into OH minus. So here what I am writing, H plus ion concentration into OH minus ion concentration upon water. Understood? So equilibrium constant can be written by what way? Product concentration by reactant concentration. This is product, no student, hydronium ion into hydroxyl ion by water. Up to this understood? Copy it. Now see, this water is a weak, it's a weak electrolyte, means its ionization is very less, no? So can I say this water is a constant, student, because it is ionizing to very less extent, no? So I bring this constant to left side. Then what we write, student, K is a constant, no? And water is also a constant. So we are multiplying one constant with another constant. Then constant into another constant, we get a new constant. That new constant, now we are calling it as what? A Kw. Now this Kw is called what? Ionic product of water. So this is what the relation for ionic product of water. It is nothing but simple. It is the product of hydrogen ion concentration and hydroxyl ion concentration at a given temperature. So what is the definition of Kw? It is the product of hydronium ion concentration. Actually this H3O plus it exists, or we can say it is the product of hydronium ion concentration, and concentration we represent in what? Brackets. Understood, student? Molarity, you know, no? Moles per liter. Product of hydronium ion concentration and what ion concentration? Hydroxyl ion concentration. Hydroxyl ion is shown with what? OH minus ion. Hydroxyl ion concentration at a given temperature, provided temperature is kept constant at a given temperature, and that product is called what? Kw. What is that Kw? Now onwards we call ionic product of water. Understood, students? So simple, ionic product of water. Here water is a weak electrolyte, so it gets ionized into H plus and OH minus. For that, when we apply equilibrium constant, how we get, students? Product concentration by reactant concentration. That's the product of hydrogen ion into hydroxyl ion by water. Now this water is a weak electrolyte, no? So its ionization is very less, so it is taken as constant. So we are bringing this constant to left side. This K is a constant, equilibrium constant, and water is also a constant. So constant into constant, we are getting a new constant, and this Kw now onwards we call it as water, ionic product of water. So what is ionic product of water means? It is the product of H plus ion concentration and hydroxyl ion concentration at a given temperature, provided temperature is kept constant. The same concept we study when we start from June 1st, equilibrium chapter we get this. Now see this Kw we wrote, no? Now consider at 25 degrees Celsius. At room temperature, when you are taking at 25 degrees Celsius, this hydronium ion concentration will be 10 power minus 7. What is that concentration? No, you are familiar, molarity. This is expressed in mole per liter. Mole per liter we write. Concentration of hydronium ion is 10 power minus 7. And same way hydroxyl ion concentration will also be 10 power minus 7 mole per liter. Then what will be value of Kw would have been asked. Kw value, how do we get product, no? That means what should I write? 10 power minus 7 into 10 power minus 7. That comes how much? Bases are same, powers we have to add. So its value is 1 into 10 power minus 14. This will be the value of Kw. What will be the unit? Mole square per liter square. That can be written capital M square. That is mole per liter. Molarity, you know, no? So these many moles are present in 1 liter. How much? 1 into 10 power minus 14. And this value will be fixed provided temperature should be at where? 25 degrees Celsius. If you change the temperature, the Kw value also changes. You have to see examiner whether he is saying at 25 degree or other than 25. So this value will be only at 25 degrees centigrade, and copy this value. How much it is? 1 into 10 power minus 14 mole square per liter square, or simply we write M square. M square means what? Molarity. Understood student, all of you? Clear? Simple, no? So write next heading, copied all of you. Now write next heading, effect of temperature on kW. And do you all copied this? This value is important. kW value is 1 into 10 power minus 14. Now we have to study what will be the influence of temperature on kW. Right, effect of temperature on kW. Right, effect of temperature on kW. Now observe students, in NCERT and in the exam also they will ask you, with increase in temperature. So when you are increasing more than 25 degrees Celsius, the kW value increases. So as temperature increases, kW value increases. What is the reason? When you are increasing temperature, what happens? Water molecule gets more ionization take place. So more is the ionization of water, more will be the value of water, kW. So in assertion reasoning they can ask, assertion as temperature increases, kW value increases. They give statement. And in JEE means you get assertion matching list of questions, statement 1, statement 2. And reason they will give, as temperature increases, ionization of water increases. So that is also true. And is it giving explanation to A? No. So A and R are true, R is the correct explanation. So here what happens to kW value? Write that as temperature increases, kW value increases. What is the reason? So in reason they ask, the reason is more is the ionization of water. As temperature increases, ionization of water increases. Understood? So with increase in temperature, as ionization of water increases, kW value also increases. For example, tell me students, at 25 how much we wrote at kW value? At 25 degrees Celsius, we wrote kW value at 1 into 10 power minus 14, no? But when I take at 90 degrees Celsius, now see temperature is not 25, now kW value is coming 1 into 10 power minus 12. Now see which value is bigger, 10 power minus 14 or 10 power minus 12. So 10 power minus 12 is bigger, no? So what is happening to kW value? kW value is increasing with increase in temperature. Why it is increasing means as ionization of water increases. Understood? So this is what effect of temperature in exam they ask. Now write next heading, applications of kW. Now from kW value, what are the important applications we have? Right, applications of kW. Copied all of you. This you understood, no? So with increase in temperature, kW value increases. Right, heading next, applications of kW. Now see in exam they ask you what are the applications of kW. Now regarding this application, see, if I know, for example, if I am knowing the concentration of H plus, by knowing concentration of H plus, can I able to find OH minus ion concentration, student? We can find. So see, if any one concentration is known, either H plus is known, I can find out OH minus ion, correct? Or OH minus ion concentration is known, we can find what a H plus ion. See how write that application 1. If concentration of H plus ion is known, then what we can find, students? Then OH minus ion concentration can be known, no? And converse. Converse means what? If OH minus ion concentration is known, we can find out what H plus ion. So understood, if concentration of H plus ion is known, then OH minus ion concentration can be found. So one is known, other we can find. See how, for example, one question you write. At 25 degrees centigrade, the H plus ion concentration is 10 power minus 8 molar. then find its OH minus ion concentration. Now, question understood. Say at 25 degree means indirectly saying Kw value is to be 10 power minus 14. So since it is 25 degrees centigrade, H plus ion concentration is given 10 power minus 8. What will be its OH minus ion is asked. Then how you approach, as we studied, Kw is the product of what and what, students? It is the product of H plus ion concentration into OH minus ion concentration, no? So as it is 25 degrees Celsius, what should be the value of Kw? 1 into 10 power minus 14 is equal to this H plus ion concentration is given 10 power minus 8. Now can I find out OH minus ion concentration? See how. Then what will be OH minus ion concentration? OH minus ion will be 10 power minus 14 upon 10 power minus 8. So bring this minus 8 to numerator, that becomes 10 power plus 8. So what should be the answer? 10 power minus 6. Unit will be mole per liter, or we can even write capital M. So are we able to find, if we know the concentration of one, we can find out the concentration of other or not. This is what the illustration will give. So this is application 1. Any one can be known, other can be found. If H plus ion is known, OH can be known. If OH minus ion concentration is known, H plus ion can be known. Right, last application 2. Copied them all of you. This is application 1. Now last one, right, application 2. Now what is that application 2? You know in 10th standard pH, we can know the nature of solution, whether it is acidic or basic or neutral. Application 2, right, nature of solution. What is nature means, student? It is whether it is acidic or basic or neutral. Now see, if the H plus ion concentration is more than OH minus ion concentration, H plus ion concentration is coming more than hydroxyl. What is its nature? Acidic. No? Are we able to know the nature or not? Acidic. If H plus ion concentration is less and OH minus ion concentration is more, what will be the nature, student? Basic. No? This will be basic. If both the concentrations are coming same, H plus ion concentration, how much it is, hydroxyl ion concentration is also coming same. What does it mean? It is neutral. So are we knowing nature of solution from Kw or not? And acidic means might be studied in 10th standard, pH will be less than 7. Here pH will be how? More than 7. Here pH will be equal to what? 7. And in the next class we discuss what is pH and we do some numericals on pH concept. So today I am concluding here. Till now our discussion went on what are basic radical, what are acid radicals, and in that what are the various types we discussed and how to write Crisscross method we wrote. Later I taught you today Kw. What is Kw? Ionic product of water, and what are the applications of Kw. And tomorrow we continue with pH concept. Hope you understood all of it. So I am ending the session. Wish you all the best. Once tomorrow revise and come the concept today what I taught. Right.